Okay, so we were discussing computer architecture and organization. So till now we have discussed some basics. So we have seen the definition of computer architecture in the first lecture. So basically, it is the science and art of designing, selecting, and interconnecting hardware components and designing the hardware bar software interface to create computing system that means functional performance, energy consumption, and cost, and other specific goals, right? So you're seeing that is a art of designing. Art of designing, not only designing, it may be selecting. Maybe there are things which are already designed. We have to select appropriately and interconnecting. After selecting, we have to interconnect appropriately and the hardware components like registers, processors, memory, the control unit, etc. And designing something new, maybe hardware, software interface to create computing system. Interface is also a very important thing. It's how the humans or external machines or systems communicate with your computer. So interface is also another important design aspect in computer architecture. And so all this design, what we are focusing, we are focusing to meet the specifications or requirements. What are the requirements? It can be functional requirement, right? Functional requirement can be like a chip or a computer for smartphones, a computer for drones. A lot of applications you can say the drone. We need a processing for drone image processing. Or we have robots. We need robots, process computing system for robots, right? And different application, robots in the military, robots in the industry, all those things. All this needs specific processors, computers. So we need to meet the functional performance, functional aspects or performance aspect. We need very high real-time processing for drone. So very high speed is required, and power consumption should be less because it is a battery held, and area also should be very less in a drone processor. And maybe there are some small, maybe for smartphones also, we may be told to design a computing system like a DSP kind of thing, right? This also should be optimized for battery for power, and area also should be less because these are embedded gadgets. Okay, so different functional requirements are the power requirements, area requirements, and other specific requirements. So this can be done if we have good idea about the computer architecture. So what kind of architecture I need in specific applications, right? And the general purpose computer which we are using is also a computer only, but it is a general purpose. It is not specifically focusing on any simple or any specific application. Okay, so then we discuss what are the things we will discuss in this course. Basically, all these different units in a computer we'll be discussing. For example, let's start with. Let's start. We need to add two numbers. So first of all, our functional requirement is addition. So we know we need a unit which adds these two numbers. So we can say called adder. Okay, so I draw like this is an adder, so it can do addition, right? So addition of what? Addition of two numbers. So I have to input these two numbers into the adder, right? And I need connecting wires. I call buses or line. So I can say conductors. So line one or line two. We'll change the terminology later. And I need to connect this output of the adder to some other device. So I need another line for output, line 3. Okay, so these are the conductors, just taking the input to the adder. So this is the adder. So our problem is addition of two numbers, adding two numbers. So first we need an adder, we have done it. We are done with adder, then we need lines to connect input to the adder. So we have connected lines called buses, maybe multiple lines. Maybe we need 4 bits simultaneously, for example. Okay, then what we need some initial storage so that the numbers can be driven to the adder. So I call this register or data storage. Register 1, number 1, and register 2 for number 2. Okay, for this will be stored temporarily, and output also I need temporary storage to store the output value. Added register 3. So I have 3 storage areas from where my input is going to the processor or the adder, and the output is I'm storing the result. Now this is sufficient. Yeah, it may not be sufficient because sometimes I need to use some other numbers which is maybe stored. Maybe the numbers are coming from some memory locations. So I need to have some memory, big memory, so that I can store this intermediate values, or maybe these values which is defined, or maybe I had to store the result in the memory. So I have different locations, and each location memory had two things. One is address. Maybe this is address. This is address part, and this is data part. So memory had two things: address and data. Address starting from 00, 01, 02 till here we have 99, for example, right? So this memory is somewhat slow, so that is why I'm using the registers. For example, I can do away with registers also. If I can directly access the number to the CPU or the adder. I can directly use memory instead of going with the registers. But the problem is here it will be very slow. So that is why I'm use some registers which is much higher, which is much high speed, acting in much higher speed. I don't need to wait for this memory operation. It's quite slow. Memory operations are quite slow, maybe thousands or 10,000 times slower than the processor. You have seen this, the processor memory disparity, or the gap, processor memory gap, performance gap. Okay, so that is why we use some kind of registers. So uh, instead of directly putting the memory variable directly into processor and wanting and making processor wait, we directly give values to the registers only. Okay, and we may have also a connection between the output register to the memory pack, output register to the memory, so that it can store the. So memory can not only store it, can load it and store it. Loading means taking a value from the memory and loading to some data or some memory element like register or flip flop or RAM or whatever. Okay, and what is storing, which is some result or whatever number input from the user has to be stored somewhere for future. That is storing. Okay, so we have memory, we have registers, high speed memory, we have adder, right, and output. Now sometimes the user also has to give some input to the system. So we need some input output unit. So this is for a input unit, so that means it's going to take something from the user, some data from you. So this is input unit, and this may be directly given to this input, may be directly given to some register, and there may be some other unit called output unit or output register, where the result from the processor or the result within the motherboard or within the system CPU has to given outside to the outside world. Maybe it is also connected to some register, maybe register 3, right? So all this consider simple architecture. I'm just designing an architecture according to my choice, just randomly putting a lot of registers, a lot of input output unit. Now we have already memory, we have the processor, we have the input output unit. Now the main part is, yes, control unit. We need a control unit also to control all these operations, right? So we need a control unit. Okay, so this, what is the control, is very important unit. The control unit controls and coordinates, regulates the operations of each of other units. So what do you mean by that? So the simple meaning is, control unit is this unit which tells the memory whether it has to load or store. So it has some control over the memory unit. It stores whether it has to load or store. Control unit also tells the your arithmetic logic unit or the processor or the computation unit whether it has to do addition, subtraction, multiplication, division, logical operations, whatever. Okay, so this is also a job of control unit. Not only this, control unit also has to control the input output unit also, when it has to take data from the memory or the processor register or the output into the output unit. Also, it also controls the input unit also, whether when it can take the input from the input unit and where it has to store. Okay, so control unit also has very important function of controlling and regulating. That means it also decides when this input are going to the processor, and when this output is going to the output register. So the control unit also control this very important aspect. This is called timing and control aspect. This also is done by the control unit, right? and this also can control when this input is going to the registers also. So all these things are controlled by the control unit, and especially you've seen in memory, definitely it will controls when it is storing, when it is loading, and what is the operation, loading or storing, whatever. So this is also controlled by the control unit. So control unit generates some signals like clock for coordination, so that all the units can coordinate accordingly based on the clock edge. So clock is the then enable signal, load, store signal. So all these signals coming from the control unit is called control signals. Control signals. Okay, there's a very important part, control signals. Now we have completed almost all the hardware aspects, architecture aspects, functional aspects. We have adder, arithmetic logic unit, memory storage, fast memory storage, register 1, register 2, slow memory storage, memory, RAM or primary memory, which has more locations, less speed, but and we have output register, which is again a memory. Now we have input output unit, which can take input from the external world, output unit, which can send um, output to the external world, and we have control unit controlling the all the control and coordination by help of control signals. So this completes the overall view of a CPU or a processor. Now, what is the input of the control unit? Input of the control unit is something instructions which is given by the user, which can be stored in the memory also, or can be some algorithm executed. Okay, so the control unit will be taking some instructions. Okay, so some instructions, for example, adding two numbers. This is an instruction, it can be written like add n1 n2, something like that, for example. So this is going to the control unit. Now based on this instruction, control unit knows, okay, I need to give this control instruction for, so the ALU, it has to show that, it will tell that it has to do addition, and we need to on these registers, and the input is coming from R1 and R2. So likewise, the output is going to R3, right? Or maybe it has to control the memory unit. Maybe the inputs are coming from the primary memory. Okay, so all these things, and after the process, maybe output, I have to do some output. So then I have to give instruction out. So it'll tell the output register R3 storing the result, give the result to the output unit. It also tells the output unit be ready, enable by enable signal, load signal, right, and clock. All these are coordinated by clock. Not necessarily, can be converted. So it's option. So it's up to the designer what kind of synchronous, asynchronous, what kind of processor you are design. Okay, so this complete, you got overall idea of uh, why all these important units are required. So basically, I want to tell one more thing. The control unit is functioning based on a lot of switches. For example, there are a lot of switches actually. So instead of these lines I'm showing you, this is actually acted by a lot of switches. That means the control unit is controlling this by switches, just simple switches. This is S1. Now this another switch S2. Now output switch is S3. Right. So control unit is just pressing oning and offing these switches. And there is some switches in load area have some switches. This is load switch. And if it is zero, store switch, and a lot of switches, not resistors on, and these switches are transistors, nothing but MOSFET or BJTs, usually MOSFETs. So just using switching on and off, and this is here also there is a switches, output switch, and input switch. So all these are controlled by the control unit. So control unit controls those switches, maybe MOSFET controls the MOSFET. That means control the gate of the MOSFET and decides when to on and off this. So basically, it's very simple. Understand the conceptual understanding should be very simple. Control unit is controlling the switching operations. Different switches, different buses are kept on and off, even from the memory to the register. Okay, and there are other functions other than switching also. Maybe control unit also need to give which register has to selected. Maybe there are 10 registers or 8 registers. Among these 8 register, your data has to go to which register. Output also, we have multiple registers. Your output value has to go to which register. So it has a multiplexer also, it need demultiplexer also. This is this overall thing. Okay, so that's about the overall processor. Then that's about the processing. Then we are focusing on the instructions. Now we are focusing on the instructions. Focusing on instruction and how the instructions are decided or framed. So first of all, we should know that any computer is working on some made 3 steps: fetch, decode, execute. Okay, so what is it is executing or what it is fetching, what it is decoding? This is because of some problem. You are always working to solve some problem. A computer is a machine which is always working on some problem or helping human beings to solve a problem. Maybe it's addition, subtraction, division, or some other complicated problems. So these instructions has to be predefined. I have to predefine this instruction before I can give to the control unit. So these instructions are coming from some kind of a problem. So to solve a problem, we'll make an algorithm or a flowchart, which we discussed. Okay, the idea, the logic to solve any problem is called algorithm or flowchart. And based on the algorithm, we convert this algorithm or flowchart idea or logic into instruction based on the processor we are working on, processor or the computer system we are working on. Because instructions are depending on hardware. Instructions specifically, maybe some computer has multiplication, some don't have multiplication. Some will be doing division, some will be doing subtraction, some will be doing division by subtraction. So unless we know the hardware closely, we'll not be able to make the instruction, which is called assembly language instruction or assembly language program. Assembly language program. Okay, fine. So now the question is how we are going to frame the assembly language problem, a language program. Basically, we are working on some simple problem and we make a step-by-step solution for that algorithm or flowchart. Then we'll convert this logic into a set of instructions. So instruction can be at any different levels. We have seen an assembly language, high-level language like C, CPP, Java, Python. They are high-level languages. But assembly language programming is closest to the hardware. A person who is doing assembly language programming, he should be knowing the hardware very closely. What are the registers, how many registers, what are the operations, and what are the memories, right, and all those things. Okay, so before that, going to assembly language, you should have our logic very clear. This is a very important part of a computer scientist or a computer engineer, to have a logic clear. Say for example, we are taking some simple problems. So here also I'll take, say, find the largest of two numbers. You should have a clear cut idea, step by step. Find the largest of two numbers. So how we are going to solve this problem? Find the largest of two numbers. So we should know that some people prefer the algorithm. So we may go for algorithm. What is algorithm? Step one. So I'll start step one. What is step one? Step one is nothing but input. I had to take these numbers as input. So step one is input. Input number one. Number one. Okay. Now step two. Maybe I can store the number one. Store number one. Step three. Input number two. Second number. And step four. Maybe we can store it. Store number two. Then compare. Step five. We can compare number one and number two. Compare, or we can say, instead of comparing, this is a more top level instruction. Let's uh, checking down level what happens. So to compare, we'll check we'll check check if n1 greater than n2. Check if n1 greater than n2. Then if it is yes, usually we don't tell if yes, we tell if else, we'll go for else. If it is true, we'll go to next statement. So we'll write like this. If n1 greater than n2, else go to some step we have to jump. This is like a looping, we have change of control, decision making statement. Check if n1 greater than n2. If it is true, we'll go to step 6. If n1 greater than n2, then output n1. Else go to step, now we have step 7. Now step 7, output n2. Then step 8, Step 8, I should know step 8. Okay. Step 8 is, sorry, I'm writing. Stop. I can stop it. Now you can see right now we can see output after output N1. You can see here. I hope this is not looking bad. So step 6, we are outputting N1. Now you have to stop. Now go to step 8 where I have to stop the program. So I'm going directly jumping to stop after printing. Right. Okay, so this is a simple algorithm, step-by-step instruction I'm giving to the computer. First is inputting first number, storing it, inputting second number, storing it, again checking if n1 is greater than n2. If n1 greater than n2, what happens? I need to print n1. So uh, I'll go to step 6. From 5, I'll go to automatically go to step 6 and output n1 and I'll go directly to stop. If it is not the case, if n2 is greater, then I'll go to step 7. That means I'll output n2 and automatically I'll go to step 8 stop. So that's it. This is only 8 instruction. But what is the problem in this? What are the things which can go wrong? This is a very simple thing which are inputting two things and checking if one is greater than another, and if that is true, printing that number and stopping. So this is called algorithm. I'm going step by step, step 1, step 2, step 3, step 4, and there's a decision. You can see the decision where the decision block here. Decision block here is this. This is a decision block here. Decision block here. Okay, so let me draw the flowchart also, so that then we can discuss the problems of this kind of thing. Okay, so let me draw the flowchart of this. Okay, so input first. So flowchart, it is pictorial representation. Instead of this word by word, I'm drawing pictorial representation. So I'll start with start. Start and stop is rectangular with rounded edge. Now I have to input two numbers. So input and output is done by the parallelogram. So I can just write like this: input n1, n2 for the simplicity. I don't want to be elaborate in flowchart. I need to be simplicity. I just add less numbers, less wordings. Right now, input two numbers. So by default, I don't need to write again store something. So input n1 is already there. Now I can directly come to decision statement. If is n1 greater than n2? There are two possibilities, yes or no, right? In the decision, there are two possibilities, yes and no. So maybe I'll say if this is no, if this is yes. If it is no, we know the largest number is definitely n2, so I can write print n2. Print n2. So larger number I'm printing print n2. Else, if it is true, n1 is greater, then I have to print. So I don't have space, so I'll just draw here. So I'll do print n1. Okay, then after this two cases, I have to just stop the execution. So again, stopping, like starting, is rectangular with rounded edge. Arrows are important. Now this is a connector. I need a connector here, so I just put a circle and I put a number or label 1. Now this will be joining in the bottom 1, right? This is called label or the connector. Circle is always the connector. So you got why we use the connector. Okay, so connector is used for joining. Maybe one part of the flowchart I couldn't draw here, so I draw the other way, and the label should be same. This is 1. It's also 1. Okay, so this is flowchart. This is algorithm, and this is the flowchart. Flowchart is pictorial representation. Some people prefer flowchart. Some people prefer algorithm based on their learning. Not only learning, maybe their interest or their kind of the way they learn. Some are verbal learners, auditory learners, visual learners. All those different kinds of learning mechanisms. So this is what are the problems which can happen to this simple algorithm of finding largest of two numbers? Yes, Abhay is told equality has not taken into consideration. There is some problem if both n1 and n2 are same. So personally, what I propose, I also propose the flowchart way. my way of doing the problem is I will think in terms of flowchart. Some may be thinking in terms of algorithm. That is perfectly fine. So for my case, I'm thinking if I am giving two numbers same 8, 8, then I'll get a print that what greater number is 8, something like this. No, I'll go to no 8 greater than 8, 8 greater than no. So I'll go to the print 8. So that is a wrong output, because I expect my program to print the greater number, largest number, but I'm getting some number like 8, which is not greater, because actually it should be a option like equal, should tell that equal, or there is no output. Something should come. I should get an output here because both are equal. So if I get an output, that means I think that this 8 is greater number, which is not right. Although the result is should be equal or no output should come. Right, here the same case here. If n1 greater than n2, if 8 greater than 8, the answer is no. So let's go to step 7. So again, I'll print 8 in n2, step 7, and stop it. Okay, so which is also I don't want. So I need to change something here to check if they are equal. Okay, so what is the best way? Best way is you have to start from scratch. You can start from scratch. I'm just writing the flowchart. Say you start, then input n1 and 2, then immediately you can check is n1 equal to n2 or equal to. You can just don't need multiple equal to, only single will also do. In C and other program you may find this thing, but no need to worry. In flowchart there's no much rules like this. Is n1 equal to n2? Immediately you are checking this that they are equal. So if they are true, you can immediately, if this is yes, make it immediately print equal. Print equal. You can print that they are equal. So whatever need to print in the output display, I'm just putting in quotes equal. Then I can definitely stop my flowchart. Now if they are not equal, now I can continue with the earlier idea. Is n1 greater than n2? So here it is no, that means n2 is greater, print n2, else yes, I can print n1. Print n1. Okay, again I can, this two will be connected like this, and I can go to stop here. Simple. All arrows has to be. So this is the complete. Now there is no other problems here. Even if they're equal, they are equally, and if greater number is printing. Okay, so this work is all cases. This can be used for programming. Okay, then after this logic is clear, then you can go for any program based on the instruction, or any assembly language based on the instructions. So the most important thing is you should have something in your mind. So this comes by just simple practice, right? So let's see if we can have three numbers. Find the greater of three numbers. Find largest of three numbers. Find largest of three numbers. Okay, here this ideally we assume that three numbers n1, n2, n3, they are not equal. So first you should start with the simple. You should not assume all the complicated scenarios. Let's take the simple example. n1, n2, n3 are different numbers. So likewise, we have to start, input all those numbers. In mind, you have an idea. First, I need to start. First step is input, and second step, let me compare n1 and n2. Is n1 is greater than n2? Okay. So if this is true, there are two options. There are two options. But this is yes, and n1 is greater. Another option is no, n2 is greater. Now what happens? If n1 is greater, then I have to compare, check is n1 greater than n3, right? Here also again two options, right? If yes, I know n1 is the greater number, print it. No, if this is no, I know n3 is the largest number here. Now come back to here. If n2 is greater number in this control loop, is n2, I have to compare with n3. If n2 greater than n3, yeah, I'm checking it here. So you should know. Just this is kind of mixed way of writing. Although you're trying to get a plan. Is n2 greater than n? Two options. This is no. Another option yes. If yes, that means print n2. Print n2. No, add to no, print n3. So again, I'll go here, print n3. Now after this, again, definitely stop. Okay, so this is the case if we assume that all the numbers are different. Now what happens if there is an option that if these numbers can be equal, if any of these two numbers can be equal also, so that means we have more options. We have to check all the different options, right? So here, but interestingly, you don't have to go very complicated. You don't need to check other option here. You can think about it and see that I don't need to have an extra option check whether n1 is equal to n2. I can directly check this, even if yes or no, even if n1 and n2 are equal, doesn't matter. Doesn't matter, because anyway we need to print the greatest largest of three numbers. But still if you want to tell that largest is now the largest, then another number is also equal to n1 n2, and things can become more complicated. But at least you should have some idea. Okay, so we are not going to code that, but at least you should have some idea regarding that. Fine. Now we go for looping. So looping. Now we'll just looping. So all these things are discussed because without this, our assembly language programming is not going to be effective. We cannot mug up the program. We have to design the program. Before designing, we need to have algorithm and flowchart to be very clear. So let's have a flowchart. If you are interested in algorithm, you can do algorithm flowchart to find sum of first 100 multiples of 4. So this is a simple program giving you sum of first 100 multiples of 4, right? So what is our idea? We may think like that. Okay, we have to start. Fine, started. Then first 100 multiples of 4. So first number I should assign a number n with a 4. The first number is going to be 4. Okay, this I'm thinking assigning using a rectangular box. I want another counter, right? I need another counter to count how much I need to jump each time. Okay, I need counter, maybe see maybe I'm just randomly checking all those things, thinking, and I need to variable, I need to store the sum. So I'll put initially it should be 0. Okay, sum is stored in S. Now I need a counter should be, I need to have 100. I have to check whether the number is 100 or not. So counter should start with 1. So counter C should start from 1 to 100. Okay, so C should start from 1. So I'll checking, is C greater than 100? If C is greater than 100, then I should stop. That means stop. So two options. One is no. Another option is yes. Okay. If it is no, that means C is not greater than 100. That means I have to go on adding sum. To sum, I had to add already existing sum with say n, right? For example, we have n, first number, we have n, 4. Okay, so I'm storing the number. Now in every iteration I had to increment the n, right? Because then only we'll go to the next multiple of 4, right? Again, this is going to here. Okay, if it is greater than 100, then I have already added all these multiples of 4, 100 in number. So then I have to print what? You have to print sum or S. Then you can stop. Okay, so this is a simple loop. This is a loop. So we can see a loop. Which part of the loop is more important here? Here till this is assignment. This is all thing assignment. Now here we are starting the loop. This is the checking of the loop. This and then we go here. So the question is whether this will work or not. I want you to think and tell me whether this will work or not. Yeah, I want everyone to think and put in your chat box whether this flowchart to find the sum of first 100 multiples of 4 or find sum of first 100 multiples of any number, maybe 4, 5, 10, whatever, will work or not. Put in the chat, type in the chat, or you can unmute and tell me if you are interested.
वर्क नहीं करेगा
Sorry, not audible.
सर बिकॉज सर काउंटर नहीं बढ़ा रहे हैं सर वर्क नहीं करेगा सर
Okay. Yeah, that was his. Yeah, got it. I'll change that. That was a mistake from my part. So definitely. So I'll change the counter. Fine. So that was some random mistake from my part. Okay. So I'll do that. Okay, fine. Counter I'll forgot to change. Fine. So
then it will be work.
C plus 1. Okay. So again, I want you to tell me whether now this will work or not. Again. C and C plus 1. So each iteration is passing, my C is also getting updated. So I'm checking whether now you can update your answers. Now again you tell me whether it will work or not. You have to think very carefully. No, it will not work. Equality is not taken into consideration. No, right now I may not take equality into consideration if it is working properly. Equality anyway, C greater than 100, there are two options, yes or no. So you should tell me what is the exact problem happening. That is what I expect. If I run this and I tell that this is giving me sum of first 100 multiples of 4, the only answer is yes or no. Is it giving the correct output or not, and why it is not giving the correct output, and what is thing happening? Yeah, condition maybe C less than 100. No, C less than 100 cannot be the condition, right? Because if C less than 100, yeah, C less than 100, that also option. Then we have to change the division. No and yes, we have to interchange. 100 is greater, then we have to, yeah, that is one option, Abhay is saying. But here, what is the problem happening? That's my question. Here, what is the problem happening? Yes, type in the chat. Yeah, I expect Abhay is telling something. Yes, Ritika is telling it won't work. So again, tell me whether I'm modified the counter also. Tell me whether this will work or not. If yes, okay. If no, why? The answer is it won't work. The answer is it won't work. Why? You can see the logic here. You can maybe this is my opinion. Maybe it may work, but you can see you're checking the first condition before doing the processing within the loop. This is the processing within the loop. This closed loop is processing within the loop. So we are checking condition before entering the loop, right? Whether yeah, I think this will work actually. Yeah, this will work. What my logic was, if it was maybe we are missing one last 100th sum, we are not taking the last number into consideration. 100th multiple of 4 we are not considering. That was my thinking. Yeah, Abhay is right. Yeah, here this is another blunder we have done. So I'll change this blunder also. Yeah, this blunder. Yeah, base telling. Yeah, this should be less than 100. Yeah, I changed that also. Now tell me. After changing that also, tell me if it will work or not. Yeah. Yes. Abhay, you are right. I changed that according to you. Now tell me whether this will work or not. Okay, this again will not work. Sorry, this again will not work because Then again to change the decision condition again, right? So this also won't work. So yeah, it's also won't work. So better I should put this c greater than 100. You should remember the condition and everything. Here I have initially put c greater than 100, so again I am putting c greater than 100. Right? Why? Because yes is here. This is no option. This is yes option. Right? If c greater than 100, yes, true, I'm exiting out of the loop. That is fine with me. Else, I'm not exiting. I'm going again within the loop. So this will work. So initially it is 1. Yeah, it is adding. Second, 2, 3. So this will work till 101. Till 101, the option is no. So 100 also, I'll be adding. So 100 number also I'll be adding. So this is modified thing, and this will work according to me. Because till c is 100, this becomes no. That means 100 addition I will do, and after it becomes 101, we'll come to here, and 101 greater than 100, yes, then it goes to print. Right. So that is okay. That will not work. So I'm changing something. So let me change this thing. Yes or no? Yes or no? I'm going to change here. Let me change a bit. Let me change the algorithm a bit. Let me change. This should be yes. This should be yes. If you're going to loop, this should be yes, and this should be no. So I have to change the condition. I'll change the condition here. I'll change the condition. So I'll change the condition like this. So you see less than 100. Now tell me whether this will work or not. You can take 3 minutes. I will give only 3 minutes. After 3 minutes, I want everyone to put in the chat whether this will work or not. Yeah, no. Akshay is saying no. Others, no, because yes. Ritika is also saying C 100 will not be. Yeah. So you can see, you can think, others can also type. Yes. Akshay Tripad is suggesting the solution. Yes, the answer is that it may not work. So why? You can see C less than, the condition is changed. C less than 100. C less than 100. So when C becomes 100, maybe C becomes 100 here, no? C becomes 100. That means I have already added 99 multiples of 4 into the S. Now N becomes the 100 multiple of 4. Now C is also incremented to 100. Now I want to add one more multiple, but you can say the condition is 100 less than 100 and becomes no, 100 is not less than 100. It becomes no, and I'm printing S. That means I'm printing first 99 multiples of 4, not 100 multiples. So yeah, the solution is either you have to put greater than equal to, or you should put this, something like this, 101. Something I can change this into 101. Right? So 100 is also true. Then I can change. Either I can put C less than 101 or C less than equal to 100. Both our options are possible. There's one more option possible. I can say if C equal to 100. If no, I can go and continue the loop. If C equal to 100, I can exit the loop and print the number. So this is also possibility, no and yes. So there are different possibilities. This is the way of analyzing any problem. And once you're clear with the idea, logic, or algorithm or flowchart, then you can easily code. So same thing we will continue to code in the CPP, C, Java, or especially assembly language. Assembly language, you need to very good grip over the loops because we have very less number of instructions and we have to pick and place and load and store architecture is very difficult. Okay, so that's all from my part. So if any doubts you can ask, and parallel you can put the roll number also in the chat.